A proton moves faster and faster inside a cyclotron. But does its required frequency also keep increasing? Welcome to Samuthra Logic Block 32, the cyclotron clock. Here is today's challenge. A proton moves in a classical cyclotron. If its speed doubles while the magnetic field remains unchanged, what happens to the alternating electric field frequency required for resonance? Most students think that twice the speed must mean twice the revolutions per second. That would be true only if the orbit radius remains fixed. But does it? A Samuthra student first checks the radius. Since R equals mv divided by qb, doubling the speed also doubles the radius. The particle moves faster but along a wider orbit. Use an expanding clock hand as a memory aid. A point farther from the center moves faster and travels a larger circle, but it can still complete one turn in the same time. In the real cyclotron, magnetic force provides the centripetal force. Equating QVB with mv square by r gives r equals mv by qb. So an increase in speed produces a proportional increase in orbit radius. So the time period is 2 pi r by v. Substituting r equals mv by qb, speed cancels completely. Therefore, the classical cyclotron frequency is qb by 2 pi m, independent of speed and radius. When speed doubles, radius also doubles. In 2 pi r by v, both changes cancel. The time period stays constant, so the correct answer is C. The frequency remains unchanged. Remember this Samuthra master logic rule. In a classical cyclotron, magnetic field, charge and mass set the frequency, not the particle's speed or orbit radius. So the conclusion is, a faster proton doesn't need a faster cyclotron clock. Its orbit simply becomes wider. Don't memorize physics. Understand the logic behind physics. Follow for next logic block.